All right, so this one we're probably going to, it gives us a bit of a hint, and it says by adding 1 to each fraction. So if I look at the left-hand side, and I add 1 to, I'm just going to space these apart and show you how I'm going to add 1. So at least it gives us this hint. So adding 1 here, I would suspect the denominator is b plus c. So I'll add 1 by adding b plus c on b plus c, that's 1. And this one I'll add 1 by a plus c on a plus c. And this one I'll add 1 by doing a plus b on a plus b. Of course, I've added 1 3 times, so I'm going to subtract 3, so it still equals this left-hand side. All right, so if I do that, what do I have? So, might not, yeah, it's nice. So common denominator, so I'll do a plus b plus c on b plus c. And then I've also got a plus b plus c here, but on a plus c. And I've also got a plus b plus c here, but on a plus b, and I still have a nice minus 3 there. Now you can see if I factorize just those first 3 fractions, they all have this in the top, and what's left, we have these fractions here. All right, what can we do with that? Well, there are 3 terms. So, and we've got an inequality, and it's not like a square one, so I'm thinking AMGM. So if I've got 3 terms, remember we did it before, so if I add x, y, and z, so there's the arithmetic mean, it's got to be greater or equal to the geometric mean. And then I'm going to multiply the 3 up there, so get rid of that. So we could use that, because here, what do we have? Except if we're going to use that, we want some tops and bottoms to match, like in the other one we did. So for example, if I've got some b plus c's here and a plus c's, that's a plus b's, I want that up here. So why don't we do that by, so if I want this now to be a plus kind of b, and a b plus c, and an a plus c, now I've got 2 lots of each a, b, and c, so I'll just put a half at the front, so it's still the same as this. So it equates to that. And then I've still got this stuff here. But now there's a bit of matchy-matchy going on, so it might look a bit nicer. So if I just put in my big first bracket, if I say I'm adding, I'm adding these 3 terms, so this is my x, y, and z in here, I know that's going to be greater or equal to, okay, so the half's still there, but I'm going to put something in that's, I'm going to sub something in that's smaller, so I'm going to sub in the geometric mean for the arithmetic mean here. So what will that be? That will be 3 cube root of just the multiplication of all those. And see, it'll look nice, hopefully. And I'll do the same thing with this bracket. So there's the addition of 3, and I'm going to sub in something smaller. That's why the other side is now greater. So again, 3 cube root of, and this time we've got 1 times 1 times 1, and b plus c, a plus c, a plus b. So you can see it's looking nice now. Of course, we've got that minus 3 there. All right, so let's fix that up. We've got here a 3 times a 3 times a half, so 9 on 2. Then what have we got here? We have, actually we can put this together. So we've got the cube root of all that divided by the cube root of all this. So you can see that's going to be 1. So I'm just putting those cube roots together, and it's going to be the cube root of 1. So that's just going to be 1. I still have a minus 3. So I'm going to have 9 on 2 minus 3 is 6 on 2. So you can see, just run out of room, sorry, I am going to get a 3 on 2. So we are going to get that left-hand side is greater or equal to 3 on 2.